Hold a modern graphics card in your hand. At first glance, it looks like a simple circuit board, covered in memory chips, copper traces, and a cooling fan. It's surprisingly light, yet it can cost anywhere from a few $100s to asterisk more than a brand new car. Most people who buy one just want smoother video games, and for most of Nvidia's history, that was exactly what the company was selling, a faster way to render explosions and sunsets on a computer screen. But that same piece of hardware is now sitting inside the world's most powerful artificial intelligence systems. Inside data centers that cost billions of dollars to build. Inside machines that pharmaceutical companies use to discover new drugs, that weather agencies use to forecast storms, that banks use to detect fraud, and that every major technology company on Earth is using to train the AI models they believe will define the next decade of computing. The same chip. A completely different world. Asterisk. So how did a company that started in a simple diner become one of the most valuable businesses ever created? And more importantly, how do they actually make money? Because the truth is far more strategic than most people think. Nvidia doesn't just sell chips, it sells the ability to do certain kinds of computing that no other hardware can do nearly as efficiently. And it has spent 30 years building a moat around that ability, a wall its competitors find almost impossible to climb. To understand where the money comes from, we first have to understand what Nvidia's chips actually do. Most computer chips, the kind inside your phone and laptop, are designed to process one or two complex calculations very quickly, one after another. They are built for speed on a single task. But some problems require doing millions of simpler calculations, simultaneously, whether it's rendering the pixels of a video game, training a neural network, or simulating the behavior of molecules. These are not fast single-thread problems. They are massive parallel problems. Thousands of calculations happening at the exact same time. To visualize this, think of a CPU as a high-speed delivery van. It can carry one large, complex package across the city very quickly. But if you have 10,000 small letters to deliver at once, that one van will take forever. Nvidia's GPU, on the other hand, is like a fleet of 5,000 bicycles. Individually, they aren't as fast or powerful as the van, but collectively, they can deliver all 10,000 letters in a fraction of the time. Nvidia's graphics processing units, GPUs, were built from the beginning to handle exactly this. Every pixel on a screen needs to be calculated independently and simultaneously. So Nvidia designed chips with thousands of smaller processing cores, working in parallel. That architecture, built for gaming, turned out to be almost perfectly suited for something nobody fully anticipated. Training artificial intelligence. In 2012, everything changed. A group of researchers used Nvidia's gaming chips to train a neural network called AlexNet. It performed dramatically better at recognizing images than anything before it. The key wasn't just a smarter algorithm. It was the hardware. Running that computation on GPUs instead of standard processors made training fast enough to be practical. From that moment, the entire field of AI became inseparable from Nvidia. But Nvidia didn't just get lucky. They built something over the previous decade that made their hardware irreplaceable. And that something wasn't made of silicon. It was software. In 2006, Nvidia released a software platform called CUDA. The idea was simple. Give developers the tools to write programs that could run on GPUs for purposes beyond gaming. Suddenly, scientists, researchers, and engineers could use graphics cards to accelerate general computing tasks like simulations and data analysis. At the time, investors were confused. Why was a gaming company spending billions of dollars on a software language for scientists? Nvidia's stock actually struggled during these years. But Jensen Huang, Nvidia's CEO, saw what others didn't. He realized that hardware is a commodity, but software is a culture. Nvidia was no longer just selling hardware. It was building an ecosystem. Here is why this matters. The GPU itself is valuable, but CUDA is what makes it a monopoly. Researchers and engineers have spent years learning to write code in CUDA. Universities teach it. Every major AI framework, like PyTorch or TensorFlow, is built on top of it. Switching to a competitor's chip means rewriting millions of lines of code and retraining entire teams. The switching cost is so high that even if a competitor makes a better chip, customers often stay with Nvidia simply because leaving is too expensive and disruptive. Think of it like a smartphone OS. Even if another phone has a slightly better camera, you might not switch because all your apps, photos, and habits are locked into your current system. Nvidia has done this for the entire world of high-performance computing. The hardware is the entry point, the ecosystem is the lock. So where does the actual money come from? Nvidia divides its empire into two major segments, asterisk gaming and asterisk data centers. Understanding what has happened to these two segments over the last few years explains why this company is now a trillion-dollar giant. For most of Nvidia's history, gaming was the king. Graphics cards sold to gamers and enthusiasts represented the vast majority of their revenue. They competed fiercely with AMD for every frame per second. The margins were decent and the growth was steady. It was a good technology business, asterisk. But then the data center business exploded. Every major technology company building AI systems needs GPUs. Training a large language model, the kind that powers modern AI, requires running billions of mathematical operations simultaneously across enormous datasets for weeks or even months. Standard processors simply cannot do this. GPUs, and specifically Nvidia's GPUs running CUDA software, became the only practical way to do it at scale. Today, the price of a single Nvidia data center GPU, like the H100, can reach asterisk $30,000 or more. A single server rack can cost hundreds of thousands of dollars. A full data center housing thousands of these systems costs billions, and the tech giants, the Googles and Metas of the world, are ordering them by the tens of thousands, sometimes hundreds of thousands at a time. Here is the genius of their economics. Asterisk. Nvidia does not manufacture its own chips. They design them, and a specialist foundry in Taiwan, TSMC, produces them. Nvidia pays for the manufacturing and sells the finished chips at a massive markup. In the data center business, these margins have reached levels that are extraordinary even for the tech industry, sometimes exceeding 75% to 80% gross margins. When AI demand surged, Nvidia had a product everyone needed, with no close substitute. They couldn't produce them fast enough, and the normal rules of supply and demand pushed prices and margins to the sky. But there is a tension underneath this success. Because Nvidia doesn't control its own manufacturing, it depends entirely on a small number of foundries. If those foundries face disruptions, natural disasters, or geopolitical tensions, Nvidia's entire supply chain stops. Revenue can surge on demand, but supply is always someone else's problem to solve first. This brings us to the chip wars. The US government has placed heavy restrictions on exporting Nvidia's most advanced chips to certain countries, fearing they could be used for military AI. This puts Nvidia in a tough spot. They have to comply with national security laws while trying to maintain their massive global market share. And the competition is not standing still. Every large tech company that depends on Nvidia has a massive financial incentive to develop alternatives. The billions they spend on Nvidia hardware could be saved if they built their own chips. Google has its TPUs, Amazon has Trainium, and Meta is designing its own MTIA chips. They are all trying to reduce this dependency. Nvidia's challenge is to stay so far ahead that the cost of switching remains higher than the savings. This requires non-stop investment. While the hardware follows a 2-year cycle, the software is updated continuously. These updates make existing hardware more capable and deepen the customer's dependence on the ecosystem. There's also the strange relationship with the cryptocurrency market. When crypto prices soar, demand for gaming GPUs surges because they are perfect for mining. Miners flood the market, prices skyrocket, and regular gamers can't find hardware. But when crypto crashes, used cards flood the market, making demand hard to predict. Nvidia has tried to manage this by releasing specific mining-only chips, but the separation is never perfect. Beyond gaming and data centers, Nvidia has two other growing segments. Asterisk Professional Visualizations sells high-end workstations to architects, animators, and film studios. These customers aren't price shopping like a gamer. They are buying a critical tool for a multi-million-dollar production. Then there's the asterisk Automotive segment, asterisk. Nvidia is selling computing platforms to car manufacturers for autonomous driving. While this revenue is currently smaller, the potential is massive. Every car that becomes a computer on wheels represents a long-term customer relationship for Nvidia. This reveals the core of Nvidia's philosophy. Asterisk, they do not call themselves a chip company. Asterisk, they call themselves a asterisk computing platform company. A chip company sells hardware, a one-time sale. A platform company sells an ecosystem. Hardware competes on specs, a platform competes on switching costs. Nvidia has spent decades building that platform through software frameworks, developer tools, and research partnerships with universities. They ensure the next generation of engineers is trained on Nvidia tools, making Nvidia's presence permanent in every technological workflow. The Nvidia is now evolving again by selling computing power as a service through their DGX cloud. Instead of buying a $30,000 chip, startups can pay for GPU access by the hour through the cloud. This turns lumpy hardware sales into smooth, recurring monthly revenue. It makes the business more predictable and far more resilient to market cycles. When you look at it all together, Nvidia's story is two stories. It's a technology story about building the best hardware and a platform story about making it impossible to leave. Neither story works without the other. The technology must be superior, or the moat becomes irrelevant. But the platform must be deeply embedded, or the technology advantage won't last. They have been growing together for 30 years. The next time you see an AI do something impossible, whether it's generating a lifelike image, translating speech in real time, or diagnosing a disease, remember, it's likely running on Nvidia. Not just because they had the best chip, but because they made sure that choosing anything else would cost more than it was worth. They didn't just predict the future. They built the engines that drive it. And as long as the world remains hungry for more intelligence, Nvidia will be there to sell them the tools to create it.